Hi, everyone. My name is Henry Weintraub, Associate Principal at ZGF Architects. First, I want to extend a huge thanks to everyone at Boston Valley and the ACAW team for their tremendous generosity in bringing this research project to life. And in addition, also wanted to thank Susan and Christine for their deep expertise in architectural ceramics, which was invaluable throughout this workshop. So our project for ACAW is titled A Flexible Terracotta Facade. Is it this one?
We click to proceed. Yeah, one.
Thank you. So a bit of an introduction to our team. ZGF is a firm of over 800 employees across 7 offices, originating in Portland and typically associated with the West Coast. While relatively new, the DC and New York offices have expanded greatly in recent years, and our offices frequently work together on projects on the East Coast and typically the Midwest, and an example of that is our team here today. So our ACAW team consisted of Kate Mann, the New York design partner, who was not able to attend, myself, Jesse, and Abdullah from the New York office, Rebecca and Ben from the DC office, and Drew, who's not able to attend, from the Portland Fabrication Shop. And Pat Hoppel from LERA's New York office was an amazing part and partner of our process for structural engineering. So in starting this project, we set out to make something which was distinctly ZGF, not fully understanding what that would mean. And so we kind of went back to first principles, and we were guided by ZGF's essential values of, as you can see in some prior projects, mission-driven design, project performance, and social engagement. So, next slide. Oh, thank you. Our team created a menu of possible avenues of terracotta exploration, mostly centering on building performance. In early discussions about the nature of terracotta with the ACAW team, however, we found that our interest tended towards flexibility of the building skin. So through this process, we conceived of a terracotta facade system which could be transformed after installation, using components which are tactile, interactive, and engaging, but also simple, modular, repeatable, and most importantly, constructible. So much like terracotta itself is a material contingent on process and transformation, we sought to have our project explore the possibility of what we called radical flexibility in a terracotta facade system.
So our big idea in the beginning was this modular tessellated fabric that could move and undulate with the facade. Boston Valley kindly encouraged us to maybe scale that down a bit and start with one step, which was to focus on maybe a rod attachment and the terracotta patterns, and just literally creating an attachment to a rod system. So we started with studying lots of different variations of the pattern and landed on a simple and repeatable triangular pattern, and got to working on those pieces. So we created an identical form. It's the same form repeated, rotated around, all designed with the intention of slip casting, but they were ram pressed in the end because of the quantity. And we worked quite hard on the vertical rod system and the terracotta attachment to it. So we thought of a few different options, one being index quadrants that could rotate and lock in. So our final assembly is being passed around the room right now that you'll see. It's a different variation of this. But we also thought about a traditional ball bearing system and how those can rotate, as well as another slot system. So the form itself, we studied the pattern and with the intent of creating some rib texture on it that would play with the glaze and the light and help suggest that movement and interchangeability. And also looked at lighting studies. So this is a facade application and has a lot of power to influence the environment of the interior.
So one of the great things about ZGF is we have an in-house model shop, which we're able to do full-scale mock-ups, which we're able to test here, and these mock-ups kind of expedite the design process for the team, which can lead to faster production in other areas.
Ben was also a little ahead of the curve on some of the challenges we're going to run into here in the last couple of days. So again, the value of prototyping kind of proved out some of the things that we were seeing in foam and plastic are actually going to be challenging in real life. More on that later. With regard to the glazing, we developed a module that we felt pretty good about. The module has kind of two facets to each piece as it rotates around. And within that, there was a lot of potential for different glazing schemes. What we ended up on was option 3, so basically just having the same glaze on, the entire face, but having the two faces be different. And in conjunction with the movability of the modules, just getting a different tone, one being kind of a more glossy, one being a more satin, but basically emphasizing the rotation. And as we were developing the glaze studies, the glaze actually pushed back on the final form that we ended up going with. So we had an idea about how many flutes and how many grooves we wanted to have, but as we got the glazing samples and started to understand more, working with Andy, and the rest of the team, the way the glaze runs away and breaks from those peaks and valleys, it actually ended up helping us select the number of grooves. I think the final number was 7 or 8, but you can see, depending on how tight and how deep those grooves are, the glaze acts different ways. So the glaze wasn't just an applique, it ended up actually informing which shape we went with. And then in the final glaze selections, this actually gets back to the roots of this project for us, where we were working on a project at Carnegie Mellon. It has this kind of rich heritage of terracotta on campus with the Guastavino stair, and also just kind of historic friezes with these great kind of purples and greens, and getting back to this organic kind of green nature, green color motif and feel that, again, ties us back to kind of a bigger project that we were looking at in real life. So as we get into the drawings, the dimensions, the detailing, it all kind of looks simple on paper. We kind of drew and tried to anticipate as much as we could, but if anybody's paying real close attention to some of these details, you'll see some pieces might look a little tight. Again, more on that later. And then Pat from LERA kind of worked with us and Tri-Pyramid to develop some really great hardware. Again, kind of the secret sauce to all of this installation is that we have hardware that allows it to pivot. It's not a fixed kind of static thing that you think of when you think of a terracotta wall. It's just kind of fixed. But in order to do that and do it in a way where the hardware doesn't necessarily take center stage, it just kind of facilitates the magic. It's all concealed. Concealed fasteners is always hard, but this one in particular allows us to rotate every 30 degrees. So there's flexibility, but within some kind of order of degrees. So in developing the spacing, it's going to be hard to kind of wing this. So we developed some 3D printed jigs working with Ben and Drew and some of our staff in the office, and that allowed us to get kind of fewer moving pieces as we started hanging our actual moving pieces. And so from there, this is where things got interesting. So I'm sure many people had this kind of head-scratching moment as pieces started to go in, but we kind of took a step back and we're finding that a number of our hardware pieces, very high precision, maybe low tolerance, and the terracotta wants to do its own thing. I think the quote maybe from Eric or someone else that the material always wins. I think they got the better of us for, maybe 12 hours, but we ended up with some help from Andy figuring out how to make some adjustments to give ourselves a little bit breathing room, a little bit more flexibility to kind of get the highly precision machine parts to play nice with the terracotta. So again, level 1 was just getting things plumb and square, the hardware, the steel, really good representation of what Boston Valley probably runs into regularly, where maybe the existing condition is or is not exactly what you planned for, and you have to figure out how to adjust and build in that tolerance. Just getting things plumb and square, a lot of shim action, a lot of foam, but once things get plumb and square, it gets a lot more easy to rotate the panels to keep them from knocking into each other. Also work, as Christine was floating around and pointing things out, non-uniform shrinkage. I don't think it was something we could really calculate for, but the shape of the module itself kind of allows it to contract and shrink a little bit differently, and so planning for that was a little bit challenging when the holes that were being made in the green state, so pre-firing. So they moved on us a little bit. But again, thanks to Andy and an angle grinder, we made a number of field modifications and again, gave ourselves some breathing room to kind of get the hardware to fit and give us the wiggle room we needed to get the pieces to go on the rods. So from there, that's kind of the journey to get us to where we got to, I guess about 2 o'clock yesterday, 1 o'clock yesterday, where the thing is like, you know, you hold your breath and see if this thing can roll outside over the gravel and the grooves, and lo and behold, it came together, stayed in one piece. From there, you go outside and the whole thing transforms, right? So you're in these shops, you're sweating it out, and then when you actually go outside, it's kind of like this release of tension, and you can really start to take in what the light does working with the glazes that were developed with ACAW and everybody here, and it's just like this whole new world of texture and color and layers and just, I don't know, it was kind of a huge relief, but at the same time, you really can appreciate what's going on with terracotta and what it can do kind of that exceeds some of the other building construction materials we work with, so it was pretty phenomenal.
So looking ahead to how this could be applied to future projects, we took a look at the sustainability of the material. So obviously it's a screen, it can filter daylight and reduce the solar gain impact on spaces. But also because it's a variation, it's really able to fine tune the amount of light that you want to let in, subject to the space and the function on the inside. We also looked at the embodied carbon impact. So here on the left is a traditional rain screen terracotta system. On the right is our system. So they came out just about equal. We honestly thought it was going to be lower carbon, but learned that the steel involved both in the tension steel rods and the lintels that would be required to support it floor to floor kind of equaled what we were saving in removing Z-girts and other things. So it's pretty even right now, but there's probably some room to improve that on a real project.
And here we're just looking at the different ways we can create an opening using our system, and given the modular nature of the system, you can create so many openings just by removing pieces depending on where you want the opening to be. And this is just the beginning of future studies where we're looking at how it can be applied to a building. It can be used as an arcade, so you're walking through the experience, or it can be also used at a freestanding screen, and also maybe as a rain screen cladding. And the idea is that we want this to be an engaging experience, like Henry said in the beginning, so there are many ways you can rotate and transform the building facade.
So having said all that, I think we set a series of goals in terms of radical flexibility and performance and all that good kind of stewardship goal. But I think an element that came out of that, kind of despite all the technical challenges and making things work on site, is, okay, our quote did not get cut off, is that there's this extra layer of this thing being engaging and delivering on an experience, not simply a surface. So this was a quote from Christine's lecture a couple nights ago, but it kind of, it speaks to the extra layer. It's a different kind of performance, it's a different kind of flexibility, but it engages people in a way where, I think the conversation yesterday came out of this generational kind of experience and how we kind of read and engage the environment around us when we're constantly kind of engaged in our screens. How do you pull people out of that? And we talked about texture and color and pattern. And I think in our case, like, being able to physically rotate the pieces is a way to engage people and kind of pull them out of the digital funk that we might all be in from day to day. But it's a new way of engaging and delivering, again, an experience and kind of being playful with a building material. And again, just having the flexibility. I think we would encourage people to come up after and take a look, and feel free to give it a spin and try it out. And so far, it's still in one piece, so it's not too fragile. Please give it a look when you get a chance.